All right, good morning. My name is Jarero. I'm a second year student majoring in aerospace engineering.
Hello, my name is Kaitlyn Wong, and I'm also a second year majoring in mechanical engineering, and we conducted a literature review of the thermodynamics of the oxide system, zirconium oxide and yttrium oxide with Professor Luo's lab. So the objective for our research, essentially, we wanted to compare the different phase diagrams and calculations that have been published in literature in order to see if results were consistent with each other, specifically with our lab's data. So the background of our research and the problem we hope to solve. This field of material science is relatively new, since we often are seeing fluoride oxides applied for more modern and new technologies, such as the coating of fuel cells, something that we see applied in electric cars, which have been increasing in popularity within the past few years, and thermal barrier coatings, which are used for aerospace engineering, a field that deals with extremely high temperatures, or nuclear waste and energy containment, since they're able to handle the radioactive components, something increasingly popular as we try to switch to more renewable energy sources. So, fluoride oxide systems, this one in particular, has been pretty popular as of late. As a result, it becomes important to compare data with other published literature to see if results are consistent and to increase the findings of our work. For our literature review in particular, we focused on the zirconium oxide and yttrium oxide system, of which little literature exists, which we quickly became aware of during our search for relevant literature. As we looked, trying to find as much information as possible, even in literature published in 2018, there remained uncertainty in the phase diagram of the system. There were uncertainty in parameters, one rod of issues that arose from the kinetics and transformations in one part of the system, thus demonstrating our need to conduct the literature review. Should our research and findings result in finding data with similar results, we could begin looking into whether it could be used for different applications or adding other components to the system to make it even more effective. So our approach, after searching through literature, we were able to create a phase diagram using the PANDAT program, which is a program that is used to make thermodynamic calculations given function inputs. So you could give it something like, 298 plus a variable t times some constant, and it would be able to give you all these lines. So the markings on the phase diagram illustrate the values that we found in literature, which can be seen in greater detail on the next slide. Um, so matching what we found in literature to our lab's work, these little markings show what other people in literature found. We have been able to see consistency, and from this phase diagram, we are able to increase confidence in the findings about the zirconium oxide and yttrium oxide system.
So results and discussion from the phase diagrams, the functions and the parameters we found in literature spanning from information as early as 1951 and as recent as 2018. The results and data are consistent with the curve and the shape, which can be seen in the middle of our poster here. If we look closer, some of our values are essentially on the lines we created. Although there are also some fluctuations with these diamonds towards the top lying a little bit under our curves. And there's also some difference towards the lines, on the lines towards the right-hand side. Although we do see some variations as indicated by the markings on the phase diagram, which show the values that were found in our literature review, it remains consistent overall. Despite these minor differences in our data, we can see that they come to construct the same shape that we have in the diagram. For our future work, since we see that the data has remained consistent throughout the years, especially throughout the last few decades, we can further study its applications, potentially expanding its use beyond fuel cells and thermal coatings. The system has been gaining attention due to its vast potentials, which remain to be fully explored. Additionally, while it has a lot of potential as a material for engineering, we must compare how useful and effective it is in comparison to other materials. Furthermore, during our search for literature, we came across other fluoride oxide systems that include another compound in addition to the zirconium oxide and the yttrium oxide. As a result, once we move beyond the two-compound system, we must investigate whether adding other compounds would be beneficial and to what extent they would be. For example, does it exhibit other useful properties for engineering? Is it significantly more effective in the properties displayed in comparison to other two-compound systems that we've been investigating? So yeah. For an acknowledgements, we would like to thank everyone who helped us throughout our gear journey, specifically Dr. Luo, Dewei Cheng, and Mingde Chin, our mentors. All of them were there to answer our questions and set apart time to discuss what work we would be doing, and these guided us along the way, especially Mingde, who guided us through what concepts we needed to understand for the work of the lab, and then apply this knowledge in what would eventually become the poster presentation. We would also like to thank the GEAR program for allowing us to have this research opportunity as undergraduate students. And lastly, we would like to thank Vet, our graduate student mentor, who looked through our work and provided helpful feedback, especially through this poster. And yeah, just guiding us throughout our entire research. So thank you.